Welcome to the show. Today I'm diving into the fascinating world of large language model applications. Think of things powered by AI like advanced chatbots, content creators, and sophisticated data analysis tools. These are built on really innovative architectures, and I'm going to explore the current landscape, looking at both the hurdles developers are facing and the exciting directions things are heading. Our insights today come largely from a discussion in an article by the venture capital firm Andreessen Horowitz, or a16z, who are closely tracking this space. They're looking at the underlying technologies and how businesses are using them. So what are some of the big challenges right now? Well, one of the most significant limitations is the context window of these large language models. Think of the context window as the amount of information the AI can process at one time. Models like GPT-4, for example, can only handle around 50 pages of input text. As you approach this limit, the performance can really suffer. It takes longer to get a response, and the accuracy can decrease. This is a big deal if you want to analyze large documents or have really long conversations. To get around this, a technique called in-context learning has become popular. Instead of feeding the model everything, you only give it the most relevant pieces of information for the specific query. Now, you might think, why not just make the context window bigger? And that's exactly what researchers are working on. However, as the context window grows, the cost and time it takes for the AI to process information can increase dramatically, even quadratically. Imagine trying to search through a library. The bigger the library, the longer it takes to find what you need. So simply increasing the context window to tens of thousands of pages would become incredibly expensive at current rates. Another really interesting area that's still quite limited is the realm of AI agents. These are envisioned as more autonomous AI systems that can solve complex problems, interact with the real world, and even learn from their experiences. There's a lot of buzz around them, with frameworks like AutoGPT generating a ton of excitement. However, the reality is that most agent frameworks are still in the experimental phase. While they can do some impressive demos, they aren't yet reliable enough for consistent real-world tasks. Looking at the nuts and bolts of building these applications, the data pipelines, how you get your data ready for the AI, are also somewhat underdeveloped. While traditional tools like Databricks and Airflow are used, along with some built-in loaders in orchestration frameworks like LangChain and LlamaIndex, there's a real need for data replication solutions specifically designed for LLM applications. It's a bit like the early days of the internet. The infrastructure is still being built. Finally, the YouTube transcript we looked at highlighted that many current application designs don't adequately focus on logging and validation of the LLM's outputs. You send a query, you get an answer, but there's often not much in place to track what's happening behind the scenes or to rigorously check if the answer is correct. While tools for validation like guardrails and for detecting things like prompt injection attacks like Rebuff are emerging, this is an area that needs more attention as these applications become more critical. Now, let's shift gears and talk about where things are headed, the key evolving areas in this LLM application architecture. As we discussed, expanding the context window is a major focus. But even more crucial is figuring out how to efficiently utilize these larger windows. This might mean we see new types of embedding models. These convert text into numerical representations that the AI can understand and compare, specifically trained to identify the most relevant information within a large context. And this in turn will likely drive innovation in vector databases, which are specialized databases designed to store and quickly retrieve these embeddings. Experts believe that embeddings and vector databases might actually become more important as context windows grow to help manage the computational costs. The landscape of vector databases is also maturing, with open source options like Weaviate, Vespa, and Qdrant increasingly offering cloud-based solutions. We're also expecting significant progress in AI agent frameworks. As these frameworks become more robust and reliable, they have the potential to really transform what AI applications can do, enabling more complex reasoning and autonomous actions. Think of AI that can not just answer questions, but can actively plan and execute tasks. The need for better data infrastructure is also driving evolution. We'll likely see the development of more specialized tools and techniques for preparing and managing the data that fuels these LLM applications. The realm of operational tooling, often referred to as LLMOps, is also rapidly growing. This includes tools for logging, caching, tracking, and evaluating LLM outputs using tools like weights and biases, MLflow, prompt layer, and Helicon. Validating LLM outputs using tools like guardrails. These are crucial for improving the performance, reliability, and trustworthiness of these applications. We're seeing tools repurposed from traditional machine learning, as well as new ones built specifically for the nuances of large language models. How we host these applications is also changing. We're seeing the emergence of platforms that offer end-to-end solutions specifically for LLM apps, including orchestration, data storage, and more, with companies like Steamship. Additionally, services that allow developers to easily host both their models and supporting code in one place, like Anyscale and Modal, are becoming more common. Another exciting trend is the increasing capability and adoption of open source large language models. As these models close the gap in accuracy with proprietary offerings like those from OpenAI, we expect to see a surge in experimentation, fine-tuning, and wider use, similar to what happened with image generation models like Stable Diffusion. Platforms like Replicate are making it easier for developers to work with these open source options. Finally, the art and science of prompt engineering are becoming increasingly sophisticated. It's not just about asking a question, it's about crafting prompts that guide the model to generate more accurate, relevant, and useful responses. We're seeing the development of more advanced prompting strategies beyond simple instructions and examples. Orchestration frameworks like LangChain and Llama Index help manage this complexity. So as you can see, the architecture for LLM applications is a dynamic and rapidly evolving field. While there are significant limitations to overcome, the pace of innovation is incredibly exciting. Companies like Andreessen Horowitz are providing valuable insights into this evolving landscape, and it's clear that we're just at the beginning of unlocking the full potential of these powerful AI technologies. Thanks for tuning in.